All right, thanks for coming to our Spring Data in 2023 talk. I'm going to open up here with our obligatory disclaimer slide. Today's presentation is by Jens Schauder, the lead for Spring Data Relational and teammate at VMware, and I'm Greg Turnquist, the lead for Spring Data JPA and Spring Web Services. So it's 2023. Okay, yes, that's kind of obvious, but if you're wanting to build an app, what are some key components that you need to have? First of all, of course, you probably need a web layer. I don't see too many thick client apps happening this day and age. You definitely want a security layer, or it's, in my opinion, not a real application. Messaging, maybe. Some apps need it, some apps don't. Is there some vital component missing in here? Well, of course, it's data. What app is an app that doesn't have data? Maybe there's gateways as the exception or something like that, but just about every app has data. Now, Spring Data supports a lot of data stores. You may recognize some of these. The one down here is CockroachDB, for those of you that don't know that one. I personally find that repulsive, but that's just my opinion. And one thing to share is that despite 20 years of NoSQL data stores entering the market, nevertheless, it's still a huge dominant thing that people will reach for a relational database like 80% of the time when building a new app, even in 2023. So oftentimes what people are using is either JPA or JDBC. And a question I'll run into a lot is, which do I use? Should I use JPA or should I use JDBC? I mean, how do you pick? So I'm going to let Jens take it from here.
Yeah, so it's actually not just a question on do we use JPA or JDBC. We actually have within that and above that even more options like Spring Data JPA, JDBC template, Spring Data JDBC, R2DBC template, or Spring Data R2DBC. So how do we make sense out of that? First, group it by category, like the underlying technology that we are using. And we start with the simple stuff. Simple for the developers that build it, which is JDBC. And officially, it stands for Java Database Connectivity and is the protocol, the API that basically almost everything uses to talk to a relational database in the Java universe. And you really don't want to use JDBC directly. It's kind of ugly to the user because it has a lot of declared exceptions or checked exceptions that need to be handled in a very specific ways and ugly stuff like that. So you want to have something like JDBC template, which hides that from you. You just throw in a SQL statement, you get back a result. You can throw in a mapper that maps the result that you get to your objects. It's plain Java code. Really straightforward, very efficient because it doesn't really do much except hiding complexity for you. But all this mapping of result sets to actual objects is kind of tedious. So you might want to have an object relational mapper. And the one that I personally recommend is, for some weird reason, maybe it has to do with it that I work on that, is Spring Data JDBC. It's really simple. It does object relational mapping, and it does it in a smart way, much smarter than JPA. You can come to my talk that I did, like 4 hours ago, so that announcement might be a little late. But I'm sure it will be made available if you missed that. Or you go with JPA. JPA basically came into existence as an abstraction over Hibernate and a couple other object relational mappers. I'm not really happy with the way they do things, but anyway, they are the most popular solution by far in the Java universe, so probably most of you are familiar with that. And if you want, again, the repository abstraction over that, meaning you have a repository of some entity, and you can just write find by name, declare a method, and Spring Data will create all the queries and all the stuff, all the mapping for you. you can use Spring Data JPA. And then there's the R2DBC stuff, which bears the question, why do we need even more? Well, JDBC is a blocking API. And since JPA is built on top of JDBC, JPA is a blocking as well. Don't let you tell anyone anything else. If you want to have a reactive API, where you have back pressure and stuff like that, then use either R2DBC template, which is like the low-level abstraction similar to the JDBC template, or again, if you want the repository abstraction, go with Spring Data R2DBC. So that's really the different distinctions about these. So let's talk about what's new in these things in 2023. With JPA, there's like one feature that basically all Spring Data repositories have. You can have a query annotation and just write the query that you want to get executed into that annotation. And we have to massage that query. Maybe we have to create a count query out of that, or maybe we have to add limits, offsets, sorting, all kinds of stuff. And in the past, the parser we used for that, promised me to tell nobody, was built on regular expressions. And we all know that's not a good thing. But now we have proper parsers for HQL, for JPQL, for SQL, and that doesn't mean that all the bugs related to that stuff suddenly went away. We actually fixed a lot of bugs. We created new bugs, I guess. But now we are actually able to fix these bugs without breaking the ones that we already fixed before. So that's definitely a good thing. Then we have key set pagination, which we will talk about later. And all this stuff, especially key set stuff, will get into GraphQL if you base your Spring GraphQL on a Spring Data repository. That will benefit from that as well. On the other side, we have JDBC, Spring Data JDBC. And there are two major new features that we roll out: schema generation and single query loading. Schema generation was wanted by many users, and for understandable reasons, meaning you want to write your entities in Java, and then you need a schema in your database, right? The thing Hibernate does for you is it just creates it or updates it. And that is nice in development, but a really bad idea in production. That doesn't keep many people from actually doing that in production. Yeah, we don't want to like encourage this kind of behavior. The correct thing to do is use a tool like Liquibase for that. So that's why we actually create Liquibase change sets, or more, we enable you to create Liquibase change sets from your entity model. This is already a fairly complex case. To get started, you don't need this part, so ignore that for now. You need a relational mapping context, which you can normally just auto-inject or auto-wire if you have a Spring Boot application. And you need to register your entities or your aggregate roots. In my case, the minion. And then you create a Liquibase change set writer, which you give that context so it knows about all the entities. And then you write a change set out, and you would omit the last parameter. And you get a YAML file, which is a Liquibase change set, which you can fine-tune for your needs and then use for your database migrations. And if you already have a database, because this is release 23.45, you want an update, so you provide a reference to that database and pass that in here, and we will create a diff. And in that diff, we will never, ever, without your consent, delete any tables or columns. Because, we all should have one application in one schema But in the real world, we might have all kinds of stuff in the schema, and we don't want a change set just clean the database because this is not my stuff, I'm just going to throw away. If you actually want to throw stuff away, you need to write a column filter or similarly a table filter where you then get a table and column name and can decide, okay, is this allowed to, like, is this one of my tables that if there's stuff in there that isn't needed anymore, go ahead and throw it away. Or if you want to filter that, we will attach that. This thing isn't completed yet. It's the first version. It's usable. It has a couple of things that it doesn't support yet, notably references, so foreign keys don't get yet properly created, but we'll improve on that as time comes, and it's open source. We take pull requests. And the stuff that falls out of that is a YAML file like this. There are ways that you can provide Java code to decide what types to use. If you don't provide anything like that, we use defaults. And then the other thing is single query loading, which is the stuff I visit myself over actually the last years a lot with. When we are loading aggregates meaning clusters of entities. So you have an entity that has two lists of entities, and those have, again, lists of entities. We create right now lots of SQL queries to load that. And we actually found a way to do all of that with a single select, which gets a little more complex, but should improve performance by a lot. Again, similar to schema generation, it's just the first version. It only works for the methods in the CRUD repository, and it also only works for very simple aggregates. But again, we will improve on that until we support it for all aggregates and for all query methods. And with that, hand over to Greg.
All right. By the way, if you do have any questions, go ahead and ask them. Hopefully, Jens and I are sort of like the relational database guys on the Spring Data team, so hopefully we can answer your question if it comes up. But now I did mention this is 2023 and you're working on an app, and in this day and age, one thing you definitely need is observability. You may have caught some of the other talks or talking about our Spring observability story with Micrometer. And one thing we can do with Spring Data is stir in a little Micrometer. And exactly what does that give you access to? Well, it says monitoring. What does that mean? It's a way for you to analyze which query is spending what amount of time. What's the most expensive query, what's not so expensive. It gives you the insight on where to spend your engineering budget. Which query do we need to fix first? And, do I need to fix that query? That may be a waste of time. This other query is eating up 90% of the database. You can find out what to optimize. And to elaborate a little bit, if you go to your favorite website, start.spring.io, and you pick Maven, I know there's probably some Gradle fans in here too, but in order to add Micrometer to your Spring Data app, you need to be able to pick the actuator, Spring Boot's actuator module. Now in this example, I'm using Micrometer's Brave tracing bridge, as well as the Zipkin tool for reporting, but Micrometer actually supports multiple tools for actually collecting, tracing, and observability data. Now, what exactly are you doing when you're observing stuff? Well, you're tracking critical information. One of the first things is what happened, what query got executed. That's one of the things that gets traced, is show me the query that happened, and it gets logged into a tool like Zipkin. The other thing is, when did it happen? There's an element of auditability there if you turn on observability. Now, it's not a full auditing solution. In that context, you may want every transaction audited. This is more of a performance-oriented thing, so you're wanting to know when did something happen. And the other question is, how long did it take to happen? Another really powerful feature when you use the Spring observability stuff is that it actually chains together multiple observations. It has some elegant APIs, so it's very non-intrusive to your code. So things like REST template supports Micrometer, web client supports Micrometer. So you can be using these tools, you could be making remote calls, and if you have Micrometer turned on, it will track that. And then if you go make a Spring Data call, it will track that too and gather this information up with minimal effort on your end, for calls throughout the system. And another facet is that when you turn on observability, if you're not careful, you can flood the system with too many observations and it can cripple the system. So Spring Boot has a sensible default in that it, by default, will only observe 10% of all the operations. It's set at 10%, but you can take it down to 1%. You can put it up to 100% if you're just trying to, if you want to verify it's actually on. That can be frustrating when you're like, I configured it. Why am I not seeing any observations? Because you were in the 90% in that context. So you can flip it up to 100%, make sure it's working, then put it back to something that's suitable. Specifically, there's support for relational databases. If you add this particular dependency, the data source micrometer Spring Boot module from one of our teammates, Tadaya, remember how we talked about earlier that when it comes to relational databases, almost everything out there is running on top of JDBC. This dependency will use Micrometer and instrument any data source that's in the application context. And what this means is, what do you get when you're using that? Any data source-based tech. If you're using a JDBC template, it's being traced when you put that dependency in there. Or using Spring Data JDBC, it's going to be captured. Spring Data JPA, actually, that also really works because JPA under the hood is using JDBC. Now, I'm not going to go into much more detail about the specifics about Micrometer. There's a whole other talk on Wednesday at 1:15 I'd recommend you go to if that's what you're interested in.
So now let's talk about a new way to scroll through data, which is related to the keyset pagination that was mentioned earlier. In the past, we had Pageable, that is yesterday. The new kid on the block is scroll position, which is really just one part of Pageable. It works for many stores. It works for JPA, Neo4j, that's Cassandra, right?
Yeah.
It doesn't work for Spring Data JDBC yet, but that's going to. And it works like this. There's actually, we just noticed when doing the talk together for the first time in our room, there should be like something like top 10 in that query name. Then this query actually finds the, 10 first users starting at this new scroll position. Scroll position offset says, okay, I want a new scroll position, and it just starts at the beginning with an offset of 0. And it is actually an offset scroll position. What the alternative is, we'll get to that later. And then you can use that to iterate through the users that you get. So you will get the first 10 users, and then when you're done with that, you create a new scroll position and query again until your results are empty, and you're done. That is for just like processing all users in basically batches, a lot of code. So there's a similar solution with a window iterator where you basically, again, provide a method. Again, here it should say top 10 or something similar, and a starting position, and then it will produce a new query whenever it's done with one window, but you don't see anything of that because you just iterate through users, and when your first 10 users done, a new query gets executed in the background and you get the next 10. So if you are processing large amounts of data and want to do that in batches, that would be the right solution. So we had offset-based scrolling, which is basically that's what we did with Pageable in the past, but we now also offer key-based scrolling. And key-based scrolling, or the problem with offset-based pagination or scrolling is if you have a large offset, something like, okay, I want 10 users, and please start at user number 1 million. The database will actually, in most cases, load the 1 million rows for all the users and then immediately throw them away. So it still costs performance. With key-based scrolling, you basically say, give me all the next 10 users, starting with a user named Mark Pollach or whatever. And that is much friendlier for index use, so in many cases it's much more performant for large data sets. And then, of course, you can iterate through your results. And compared to Pageable, since every time you're creating a new query and the scroll position is just that, the scroll position, you have the limit separately. In the examples, on the audio line, added like you will have a top 3 in there, and but you can also provide a limit clause. We'll see that later. And you can even change the direction of the scroll position, so you can go forward, backward, and you can go 100 forward and then 10 backward, as you wish. It acts on the data it's currently seeing. So if that happens, yes, it can happen that you skip data. It's not like a live cursor that it keeps somewhere. So it's separate queries. I can actually can't read that here. Yeah, sure. Scroll-based is more flexible because it separates, on the one hand, it separates limit from offset, and it also allows, instead of offset, to use key-based pagination or key-based scroll position. You can't do that with a Pageable. And that's actually like the whole reason we came up with this new abstraction. Like the first idea was like, how can we tweak Pageable to support key-based stuff? And we realized it just doesn't work, so we had to come up with a new API. The fetch size on the database, on the database driver, is a whole different thing. The fetch size is just a hint to the driver, like, give me the results in chunks of, I don't know, 100 rows. It's probably a good idea to have that, to have something that matches. So if you have like a fetch size of 100, but constantly do a scrolling or pagination with 110, that's probably bad because it will fetch 100 and then in a separate step 10 more. You probably want to match that. But in principle, these are independent. And yeah, this is just again to like scroll position key set. Really the only difference is that you start a key set here, and you still say, like, create the next scroll position by using position at. So you take the current window and basically say, okay, of this data, of this row, make my scroll position point to that row. And in the background, it will basically collect all the relevant attributes to generate a query that looks like, get me all the users with names larger than Jens. That was that. And again, you can go backward if you want. So, NoSQL.
Now, we did talk a lot about relational stuff because, again, like I said, relational databases are still very popular, but Spring Data has also made improvements in the NoSQL front. One of the big popular ones out there is, of course, MongoDB, and something that MongoDB has introduced is encrypted fields, and so that is if you have certain data values you want encrypted in the MongoDB data store, it's not very effective to encrypt them on the server side if you're going to transmit them in the clear over the wire. So the MongoDB driver has support for encrypting these fields on the client side before it gets transmitted to the server, and this shows that in your domain object in your Spring Data MongoDB app, you can specify, this field's encrypted, this one's encrypted, and there's settings to apply theirs and what encryption strategy you're using so that Spring Data MongoDB can inform the MongoDB driver to take advantage of that. Something else that was asked for a lot from the community is one of the things MongoDB has reactive support. So there's now a reactive bulk operation feature available. So, in this example, this whole thing is a recipe. How I phrase it is that it's a recipe where it's going to do this particular query operation, but it captures it all up as a mono bulk write result. So it's a bundled operation. It's for efficiency, instead of doing everything one by one, it's sort of a bulk operation. But in case you didn't remember, when it comes to reactive applications, nothing happens until somebody subscribes to that result set. That's kind of what's in the comment below. So once somebody subscribes to that, or that's handed over perhaps to a reactive web controller in Spring Web Flux or something, where the web controller will actually subscribe on your behalf, that's now an option for you if that's what you're needing. One of the other things that what you run into is we can talk a lot like in demoware, where you have very simple queries that you write, but when you get into real world queries, you start like in relational databases, the sign that you're writing a for real query is you're doing correlated subqueries, which you have to stop and think very carefully on making that work right. And if you happen to have picked MongoDB, MongoDB has some support for correlated subqueries. Now, I'm not going to pretend that I'm the expert on MongoDB here, so if you do have questions, I may have to go get back to you on that one, but now we have additional support in MongoDB for correlated subqueries.
So we have the stuff that is already in the repositories, and but we obviously continue developing. The version that we're currently working on is Spring Data 2023.1, which we are grown-ups. We can't count base 0. This is the second release for this year. Internally, we name that Spring Data Next, and it will be part of Spring Boot 3.2. And just last Friday, we released milestone 2, I think.
Yeah.
And so hopefully we will get some more stuff in there until GA. And stuff that will go in there is Kotlin inline value classes. I'm not a Kotlin person, but I looked at this stuff, and it looks cool when you're a developer. And I looked a little and have been told about how it looks on the inside, and it's ugly for framework developers. But we went through that for you. So in the future, you'll be able to use Kotlin inline classes all over the place, everywhere except JPA, because in JPA we don't do the mapping, and that is for JPA to decide if they support that or not. I already mentioned that you then will be able to use limit instead of top n, which of course has the benefit of being flexible, and you can change that and call it with different parameters. You don't have to have a bunch of methods if you want to limit results with a different amount. For Spring Data Relational, that is RTDBC and JDBC, we can dynamically generate table and column names using spell. So that again, gives more flexibility. Cassandra will also get support for the scroll API that we just talked about. Redis will just basically maintenance of being a good Java citizen. And with Java 21, we have the sequence collection, and the Redis list will be a sequence collection that required a couple of changes. Also, an example of Redis is a change that we need to support crack. Has nothing to do with drugs. You might have heard about it in the keynote. It's about taking a snapshot of your virtual machine, saving that, and starting that up later to save all the initialization phase. So really great for scaling, but of course you can't write a database connection or an open file to a disk. So there are some things that need special treatment. This one is just an example. So we are working on that on wherever we find stuff like that. And a question? No, you can use that, but something special has to happen. Press on something. So we basically need to, if you do the snapshot, we probably have to close the data source or the database connection and then create a new one when you start that up. So, and exactly this kind of support is part of these changes. Often this will be done not by us, but maybe by a connection pool provider, but sometimes it has to be done by us. Depends on the details. Slices. Slices are like pages, but without the count. Useful if the count query is expensive. That will get support in the REST API, so you can use those there as well, and probably a lot more, but that's what we found. Back to Greg.
So in 2023, I don't know, some of y'all may have been using Spring Data for a long time. It's been out there for a long time, and it's one of the most popular portfolio projects. So we just want to let you know that this ain't your grandpa's Spring Data, okay? Instead, Spring Data 2023 is the way to the future. So I actually just was dying to put that in the deck and then work my way back from there. But now, some of the stuff questions we get to try to track things is if you're wanting to know what version of Spring Data has what, if you go to the Spring Data build, as you can see at the top, and look for the wiki page, you can find this gigantic matrix. So these horizontal columns, like this is a given, this is the current release train. And then you can see each of the models, Cassandra, Commons, Couchbase, JPA, way down here. And if you look up here, you can see the name. We mentioned 2023.1, and then if you look at this little thing, the thing is which version is for my boot 3.2 app, or which version is for my boot 3.1 app, and this is your decoder ring to figure it out. And if you look at the top, that's actually a hyperlink. So if you click that at the top, you can dive into the release notes to get the specifics. In this case, the latest one is codenamed Release Train Vaughn. It has, there's some stuff that's been added in support for the virtual threads with Project Loom, some Java 21 stuff. We mentioned like Kotlin value classes, and then the checkpoint restore stuff. So this is a handy resource to go look up if you're needing some more details about a given version of Spring Data. Now, this is not everything about Spring Data. It's some of the bigger stuff that we were talking, but you can go to, if you want to go, there's sort of an aggregate project page here at the top, spring.io/project/Spring Data. And actually from there you can find in the sidebar, you can navigate to a given submodule to go look at the one that's most pertinent to you. And one of the other things I was trying to highlight is some of the stuff is also in Spring Framework. Spring Frameworks, was the first, and so things like JDBC template and R2DBC template are over in Spring Framework. So if you're needing to know what's happening over there, you need to go to Spring Framework to find those details. And finally, at the bottom, if you're unfamiliar with the R2DBC stuff, the reactive relational database connectivity, then go to r2dbc.io, and there's some content there, some reference documents, what drivers or database types are currently supported by R2DBC. Hint, not all of them are maintained by the Spring team. There's community support for some of the other data stores out there. And you can even find the video where it was announced at, I think, maybe 2018 at the keynote, where you can find out a lot more about R2DBC. Now I invite you to get your smartphone out and take the survey, and that makes me a good team player for my corporation. And I want to say thank you, and since we still have 4.5 minutes, there is a chance, if you want to get a free copy of one of these, if somebody knows what JPA stands for. Well, somebody's got to raise their hand. And all right, sold. So, and then you can meet me afterwards in the hallway and I'll sign it, huh?
That's wrong.
What did he say?
It's wrong.
Isn't that what he said?
It's Jakarta persistence.
Oh, Jakarta persistence. He made the effort to get out of his chair. Okay, what does JDBC stand for? Close. No. Connectivity, there you go, got it. Okay, what does R2DBC stand for? Raise the hand, I can't, here. Okay, I got one more for today. So, what's another question? What's your favorite Spring persistence tool? Come on, raise a hand and there. What?
Spring development.
Okay, that's here, sold. All right. That was really hard, wasn't that? All right. So if you got more questions, feel free to join us out here in the hallway space.